Welcome to week 3 of Advanced Data Analytics. This week's topic is decision trees. We will review this family of model if you have already learned it in the introductory data analytics, and consider and study the principle behind the construction of this family of models. Okay, first things first. Let us try to build a decision tree model in a Python programming environment. This task should be trivial. So let us first from our old friend scikit-learn import tree because scikit-learn kindly provide us a family of different decision tree models in this submodule called tree, so which makes life very much easier for us. And for the data, in this example, let me disclose that actually scikit-learn comes with a set of well-known datasets. So for classical datasets like the iris, we did not need to go to the internet and download the pre-processed data ourselves. Previous week's practice is for practice, but of course, if you are looking to more serious dataset for like large-scale projects, or you need to apply the model to your workplace or real-life data, you need to master skill of acquiring and pre-processing the data. So let's see what comes with the scikit-learn dataset. It comes with a submodule specifically called datasets, and from this we can import load iris. This is a function. By executing this function, the iris dataset will be loaded for you. Okay, this is our module importing part. Yes, of course, we would like to have the training and test data split function as well. It's called model selection submodule. As you see, we for all those modules we import them from scikit-learn, but instead of import scikit-learn and refer from this root module in the following coding, I would like to import the submodules one by another. And one advantage of doing this is to save a little bit of memory, because in this we do not need to import the entire scikit-learn package, but only those submodules that is needed in this project. And on the other hand, it greatly save your trouble of typing all those from root to submodule references. And a third advantage of loading specific submodules is to save your namespace instead of let your namespace let all those different functions spread in your memory. You only have the specific functions. So say this part, in the model selection part, we need the train and test split. Run this cell. We have all those packages loaded successfully. To have the iris data, we just need to load iris. Let's run this and see what we will get. Print data. Perhaps we need to have a look at the type of the data. This type information isn't coming with much help. So it's better to have a look at what the data can provide us. that is directory. The dir means directory, and it lists all the possible methods provided by an object as well as the attributes. Remember that in Python, objects do not have their private attributes. The user can access all aspects of an object. Okay, in the data we have a description. I guess that is what it means. And data, perhaps that is the X part of the data. This probably will describe what are those features. Target should be the desirable output. Okay, the Y part and the target names should be the class names. So bearing these assumptions, let's proceed, see what we will get. If we, for example, do the train test split of the data, I don't remember the usage of this function. Let's have a look. A tip is to check the function, the document of a function, and if it provides example, we can just copy and paste example. So this may save us a lot of efforts of memorizing information that may not directly relevant to the project. Okay, so it accepts two sets or multiple sets of lists or list-like objects and split those lists into two parts. So the X part should be data.data, this one, the X part as we guessed, and the Y part should be data target. Okay, called data.target. And the test size, let's say 20%, and leave the random state not touching it. So yes, let's prepare our training and test dataset as so. Let's have a look at what we get. Xtrain. Good. Probably as expected. What is the shape of this data? Well, very good. It contains 120 samples and 4 attributes per sample. Good. Now let's construct our decision trees. One decision tree. So let's call the classifier, decision tree classifier, as tree.decision tree. As we expected, there are two sets of models in decision tree. One is classifier and the other is regressor. In this problem, we will need the classifier model. Okay, and after creating a model object, we can call it fit function. Let's use Xtrain and Ytrain to fit the model. After fitting the model, we can have a look at the model's performance. Say accuracy on train data, let it to be numpy.sum. Oh, we haven't import numpy. Okay, let's although we already be able to create numpy objects, because the NAPI library has been imported in the modules in scikit-learn, but we haven't directly import NAPI, so we cannot directly call NAPI's function yet. So let's import NAPI now and run the cell again. Don't worry about duplicate importation. The Python will deal this for us. So count the sum of all the correct predictions, compare two parts. One part is this classifier's prediction of the X train, and see how many of the prediction equals Y train. That is should be divided by the Y train's size. And copy this line of code, paste it here, change all train to test. We will get the test accuracy, or the model's accuracy on the test set. Test. Okay. Now print the accuracies. Train. Let's consider Python 3 people. Put a pair of parentheses. Copy and paste the code here. And have a look at the test. Okay, check and run. Oh, I think we get pretty good performance. Okay, now we have finished constructing a decision tree classifier on the iris dataset.